There we go. Video started. Okay. So first we're going to divide a polynomial by a monomial. I feel there's an easier way to divide a polynomial by a monomial without doing long division. And let's look at a problem. Divide 1. We have negative 12, a to the third, plus 36a minus 15 divided by, yes, you can write it that way. It means divide, right? 3a. You could also write it with a divide sign. This way, it's sort of going to tell you what to do. When you have a monomial, one term and a denominator, the easiest way to do this problem is to do this. Divide each part by it. You can only do this with a monomial, but I'm going to do each part, divide each part by 3a. And after that, we're going to simplify it. Each part at a time. So if I do the first part, negative 12 divided by 3 is negative 4. A to the third divided by a. Remember, we subtract our exponents. That'd be a squared plus 36 divided by 3 is 12. Our a's will undo themselves, so our a's are not there anymore. And then minus 15 divided by 3 is 5, but a is still in my denominator. And that would be my final answer. Negative 4a squared plus 12 minus 5 over a. So monomials, and it can only be monomials. This is the easiest way to do them. You can use long division, which we're going to do next, but this is way easier. Okay, so let's look at this problem. 10t to the fourth minus 35t to the third plus 5t squared divided by 5t squared. That's another way we can write dividing. You're going to see it both ways, written both ways. Again, we notice it's a monomial, so I'm going to divide each part. So I'm going to set it up just like I did before. I'm going to take the first term divided by 5t squared. And then I'm going to take the second term. Whoops, sorry, that's not a square, it's a cube. Divided by 5t squared plus the third term divided by 5t squared. And then we simplify each part. So 10 divided by 5 is 2. T to the fourth divided by t squared is t squared minus 35 divided by 5 is 7. T cubed divided by t squared is t. And then this will be really careful of, I have 5t squared divided by 5t squared. Just like a fraction, like 8 divided by 8. 5t squared divided by 5t squared is 1. And then that's my answer. And then we'll do one more dividing by monomials before we get to long division. So let's say we have 9a cubed b cubed minus 6a squared b squared minus a squared b minus 4a, all divided by a squared b. I'll let you write that down. It's still a monomial. A squared b is one term. So we're going to divide each and every part by a squared b. So we have 9a cubed b cubed divided by my 9s and my a's. Okay, a squared b minus. Now notice how I line them up. I put the a on top of the a's and the b's on top of the b's. That's also a really good way to do these problems too. Keep it nice and organized. So I take the second term and divide it by a squared b, and I take the third term and divide it by a squared b, and I take the fourth term and divide it by a squared b. And that one, yeah. Okay, one term at a time. 9 is 9. A to the third divided by a squared is a. B to the third divided by b is b squared. So that's the first term. Minus 6 is just 6. We have nothing dividing it. A squared divided by a squared, that's sort of kind of going to go away. And then b squared divided by b is just b. Minus the next term, okay, a squared b divided by a squared b. We just talked about that. That means it's 1 because both of them are going to become 1. Minus, okay, 4 is going to stay. Be careful of this. A divided by a squared. The a goes on the bottom. You subtract them, and because a, the squares on the bottom is bigger, it goes on the bottom, and then b is going to stay in the bottom. And then that is your answer for 3. Okay, this is only, you can't do this with anything else. This is only for dividing by a monomial. If you try with anything else, it's going to be wrong. It's only for dividing by a monomial. So now let's look at things that are not monomials. So dividing, I'm going to say polynomials because none of it's going to be monomials. Dividing polynomials. Okay, so first one, we're going to do 28x squared minus 23x minus 25 divided by the binomial 7x plus 3. So it's down to binomial. We can't do what we just did with the monomials. This is where we use long division. I'm actually going to put up here, long division. It is just like dividing in numbers. Let me just sort of write this down. I'm going to erase it. But let's say we have 125 divided by 5. How do we divide it? Of course, 5 doesn't go into 1, but it goes into 12 twice. We multiply, be really careful what I'm saying because there's a reason I'm saying it. We multiply, 2 times 5 makes 10, and then we subtract them. We subtract down, we have 2. We bring down the next term is 5. And how many 5s are in 25 is 5. I have 25. What do? I subtract them, I get 0. It is exactly the same with polynomials. It just looks different because we also have to deal with the X's and Y's and Z's. It's the same procedure, almost. Remembering subtracting is important to remember. And I know you're all going to look at and go, okay, I don't know what to do. But just go back to like regular dividing. It's just like regular dividing, just a little tiny bit different, but it has the same procedures. I'm going to erase this. And we are going to set up a long division. 28x squared minus 23x minus 25, and we're dividing by 7x plus 3. Just like a long division problem. The first thing that's sort of different about doing it with this numbers is we have to match this. We have to get 28x squared perfectly from 7x. At the beginning, we don't look at 3. We look at 7x and we look at this. And I ask myself, what do I multiply 7x by, to get 28x squared? Forget the 3. 7x, I need 28x squared. So this is what I have. This is what I need. What do I multiply this by? Well, it'd have to be a 4 to get 28, right? And an x to get 28x squared. So you line it up with your x. I'm going to multiply 7x by 4x to get 28x squared. I'm going to say it again. You want to match this, and I'm only allowed to use that. What do I multiply 7x by to get 28x squared? Well, 7 has to be multiplied by 4 to get 28, and x has to be multiplied by x to get x squared. And then we're going to multiply, just like distributive property. This we already know was 28x squared because we figured it out. And then we're going to multiply this. 4x times 3 is positive 12x. So distribute and distribute. Once you figure out what you had to multiply by, you distribute to both terms. So just like regular division, what do we do next? We subtract them, right? But I'm going to have you do something else because I find this is where people get a lot of things wrong. When we subtract them, we can't just go like that and go and do our problem because that's not true. We're subtracting both of them. So you want to change both signs because you're subtracting both of them equally. I'm subtracting this and I'm subtracting that. So what you want to do, the easiest way to think of this is just change both the signs. And you'll see that again. I'll say it again when we get to the next part. What's going to happen is this has to cancel out, which it did. That's why you have to match it. Then we're going to add down. We have negative 23 and negative 12x. So we're going to add them up, negative 35x, and we bring down the next term, just like you do with regular dividing. You subtract and bring down the next term. Now we have this new thing we have to match. We have to match their negative 35x. How do I match it? I can only allow to use 7x. So what do I multiply 7x by to get negative 35x? First, I have to multiply by negative. I know 7 times 5 is 35, so negative 5. And that's it. I already have the x. So I'm going to go up here and I'm going to say minus 5. That's all I need. And now we take that negative 5, notice I said negative 5, and we're going to distribute it. Negative 5 times 7x is negative 35x. And now distribute it to the 3. Negative 5 times 3 is 15. Minus 15. What do? We change both signs because we're subtracting both terms. To subtract both terms means I've got to change both signs. I add down, I get negative 15. That is my remainder, just like a regular problem, but there's a special way we write a remainder with polynomials. This is how you write your remainder. This is my answer, 4x minus 5, and, whoops, and plus, I had the remainder of negative 15 out of what I divided.
Is it negative 15 or negative 10?
Oh, 10. Yeah, 10. Sorry, 10. Yes, negative 10. Thank you. I saw 5s, I saw 5s, negative 10. So this is my answer. This is what I divided evenly by, but I have this remainder. This is my remainder. So 4x minus 5 is what I have divided whole, and I have remainder of negative 10 over 7x plus 3. And that's how you write your answer.
I have a quick question.
Sure.
So would it be wrong to write 4x minus 5 minus 10 over 7x plus 3? Or do you have
No.
to have the plus sign there?
No, you can have the minus sign. The reason I do this is if I have, let's say for a minute, I don't have negative 10 remainder. I have x minus 10 remainder or negative x minus 10 remainder, because that's going to happen eventually. So the reason I do this is this is why I'll show you. minus x minus 10 over 7x plus 3. Okay, this would be wrong. And that would be cut, well, let me push it up a little bit first. Okay, so let's say this is my remainder and I wrote this. This would be wrong because what I would have to do is make this a plus. Why? Because that negative has to distribute to both. That's correct. A lot of people, students get it some kind of wrong. So I always say make it a plus and just leave it the way you have it. Then you never get it wrong. But no, it's not wrong. You can do that. That makes sense a little bit. You'll see when you get into these kind of remainders. We're not going to have this kind of remainders in this class, but your next class you will. We're only going to have number remainders, but eventually you're going to get polynomial remainders, and it's really easy to mess up the negative signs. That's the only reason I do it. Beautiful. Okay, let's do number 2. We want to divide. Hold on. I want to divide 4x squared minus 6x plus 8 divided by 2x plus 7. So we're going to set it up as long division. So 4x squared minus 6x plus 8, 6x plus 8 goes under the sign, and 2x is what we're dividing by, 2x plus 7. Sorry, my dog's gone. I don't know where she's barking something. All right, we need to match that. We have that. What do I multiply 2x by to get 4x squared? First, I need a 2. 2 times 2 is 4, and I need another x. Because 2x times 2x will give me my 4x squared. Okay, now we're going to distribute 2x times 2x, 4x squared, because we made it that way. And then distribute 2x times 7, 14x. What do I do? I divide. I just divided them. I subtract, but to subtract with a binomial, I have to change both terms, the signs. That's a negative, and this is now going to be a minus. With a pencil, you can just erase it. I have a pen. I'm just going to erase it now. I mean, I have a pencil, but I can erase it. But if you have a pen, you're just going to, I don't know. They're both negative. We're going to add down negative 20x, bring down the plus 8. Now we're going to do the same thing, except this time we're going to match negative 20x using 2x. What do I multiply 2x by to get negative 20x? First, it has to be a minus or negative. 2 times 10 is 20, and I already have the x. So we're going to now distribute 2x times, oops, wrong one, hold on, 10. Negative 10 times 2x is negative 20x. And negative 10 times 7 is negative 70. We are going to subtract both terms, which means I change both signs, plus and plus. That cancels. I'm left with a remainder of 78. So my answer would be plus 78 over 2x plus 7. And that would be my answer. Hey, questions? I have one more long division. We're going to do a whole bunch more, but I have one more long division that's a little different I want to talk about. And then we're going to look at synthetic and then put it together. There's one thing extremely important with polynomials. So far, we haven't encountered it, and you don't even know what we're looking for. But let me write the next one down, and I want to talk about it. So we're going to divide. I'm going to write it a different way too. 3x to the 4th minus x to the 3rd minus 5x plus 8 over x minus 2. So I wrote as a fraction, same thing, it just means dividing. Just remember, it's not a monomial, so I can't put it under each term and simplify. It's impossible. This one I'm gonna put a star on. You could probably put a star on it too, because this one's special because it has something that we need to fix. So when you divide with polynomials, if you start with a second power, I'm gonna go back up. If you're dividing a second power, you have to have the first power and the no power, the no x. If you divide by, it's a second power too, I have to have a second power, I have to have a 1 power, I have to have the no power of x. This one, I have a 4th power, I have a 3rd power, but I'm missing the second power. Where is x squared? I don't have it. We got to do something. Then I have the first power and I have no power. So you have to represent each power starting with the first. So if I start with a 3rd power, I have to have an x to the 3rd, an x to the 2nd, an x, and a no x. If I start with an x to the 4th, I have to have an x to the 4th, x to the 3rd, x to the 2nd, x, and no x. They have to all be there. So what do? This is what we do. We're going to set it up. Basically, what it becomes is a placeholder because you're going to need that spot when you divide. That's why you have to put it in. So we're going to divide 3x to the 4th minus x to the 3rd. We're missing the x squared. So you're going to put and 0x squares, because you don't have any, but you have to put a placeholder, minus 5x plus 8. See how they're all represented? I have a 4, a 3, a 2, a 1, and a 0 power. They all have to be there, depending on what you start with. If I start with a 5th power, I have to have a 5th power, 4th, 3rd, 2nd, 1st, and none. And you're going to see in a minute how we're going to use that square in our answer. Hey, here we go. I need to match this, and all I have is x. So what do I multiply by? Well, first I have to multiply by 3. And to get an x to the 4th from my x, I need an x cubed. So notice how I'm going to line it up on top of the cube underneath it. I'm going to distribute 3x cubed times x is 3x to the 4th. 3x cubed times -2, -6x cubed. What do? We subtract them, which means I'm going to change both those signs. That becomes a negative and a positive. And I add down the 3x to the 4th goes away. And I'm going to add -x cubed plus 6, 5x to the 3rd. Bring down the next term. Even if it's 0, you're going to need it. So now I have to match this using x. What do I multiply x by to get 5x cubed? Well, first I need 5. I only have x. I need x cubed. That means I need an x squared. And see how we use the spot for the x squared? So it's like a placeholder. We need it. Now we're going to distribute. 5x squared times x is 5x to the 3rd. 5x squared times -2, -10x squared. What do? We subtract them. So I change both my signs. My 5x cubed is going to cancel and go away. Whoops, sorry. And if I add down, I have 10x squared. What do I do now? I bring down the next term, -5x. Now that's what I have to match from that. What do I multiply x by to get 10x squared? It would be a 10 and an x. Let me erase these. And now we're going to distribute. 10x times x is 10x squared. I'm only writing these arrows so you can see what I'm doing. 10x times -2, -20x. What do I do now? I subtract by changing both signs. My 10x squared is going to cancel. And I'm going to add down. I have 15x, and I bring down my last term plus 8. What do I multiply? I have to match 15x. What do I multiply x by to get 15x? 15 plus 15. I'm going to distribute. I don't have room for the arrows, but you know what I'm doing. 15 times x is 15x, and to distribute 15 times -2 is -30. What do? I subtract, so I change both signs, and I find my remainder of 38. So how do I finish the problem? Plus 38 is my remainder over x minus 2. Answer. If you can follow that pattern all the way through, you'll always be fine. The biggest thing to remember is changing both the signs when you subtract. Questions? It takes a little bit of practice. Just practice, you'll be fine. Now, let me add synthetic division. I think you're going to love synthetic. Everyone likes synthetic. I don't know, it's sort of also pretty fun. Synthetic division. I don't know what they call it, synthetic division, but it's a division of polynomials. Same thing, division of polynomials. It's sort of kind of like a really cute way to do it. When we do synthetic, we can only use it when we divide by x plus or minus some number. You can't have a number in the front. Only one coefficient. Only one. It has to be x plus or minus a number. If you have a number in front of x other than 1, you have to use long division. So this is for just binomials that don't have a leading coefficient other than 1. It's going to be x plus something or x minus something. So let's do a problem. We're going to divide 3x squared minus 2, nope, sorry, cube, minus 2x squared plus 5x minus 4 by x minus 2. And we're going to use synthetic division. Number 1, pay really close attention to the powers. I have a 3, I have a 2, I have a 1, I have a none. I have everything I need. I don't have to add a 0 in there anywhere. I have all my terms. So this is how synthetic works. It's pretty cute. So you're going to do an upside down elongated divide sign. Let me make it a little neater. Elongated upside down divide sign. This number here, what you're dividing by, think opposite sign. I'm going to divide it all by +2. It's opposite sign. We don't put the x. This has no x's at all. It just has numbers. There's no x's anywhere. No x's anywhere. Okay, now I'm going to write the coefficients. My coefficients of my x cubed is a 3. My coefficient of my x squared is a -2. My coefficient of my 5x is 5. And my coefficient of -4 with no x is -4. I'm going to put a line right here because this right here is going to be my remainder. It's always going to be that last one's going to be your remainder. And this is how it works. So I think of it as a game. How you start a game. You got to start the game by bringing down that first term or that first coefficient, whatever it is. Then it's multiply, add, multiply, add, multiply, add till you finish. So 2 times 3 is 6. Add down, I get 4. I multiply again, but this time it's 4. 2 times 4 is 8. I add down, I get 13. I know I multiply again. 13 times 2 is 26. I add down, I get 22. Guess what? That's my answer. All I have to do is write it. This is how you write it. Ready? The highest exponent was a 3, which means this one is going to be a square. It's always one less than what you started with because you divided off 1x. So here's my answer. Ready? 3x squared, follow right down the line, plus 4x plus 13 plus 22 divided by x minus 2. Done. And when you get really good at these, you can do them like super fast. So these only coefficients, you start by dividing the opposite sign to what you're dividing. This was a -2. I divide by +2. I put down all my coefficients. I have to put a 0 if I'm missing one though. How do you start? You bring down whatever the first coefficient was, which is 3, and then multiply, add till you're done. 3 times 2 is 6, add down 4. 4 times 2 is 8, add down 13. 13 times 2 is 26, add down 22. And then how do you write your answer? It's a polynomial, but it starts with one less than the one you had, the highest power. So it has to start with a square and then go right down to the end. 3x squared plus 4x plus 13 plus the remainder of 22 over x minus 2. Pretty cool way to divide polynomials. Okay, I know it's going to take more than one till you see it, so let's do another one. Let's do x to the 4th plus 3x to the 3rd minus 5x plus 4 over x plus 1. Now we're still doing synthetic. You can do long division, but we're practicing synthetic. So what I do notice though, look at the polynomial. I have a 4th power, a 3rd power. I am missing the 2nd power. I have a 1st power. I have my no power. So when I write this, I'm going to have to put a 0 in for my x squared. So first by upside down divide sign, elongated. The polynomial I'm dividing by is x plus 1. So think opposite sign. I'm going to divide by -1. Has to be opposite. Then I write my coefficient. So x to the 4th has a 1 coefficient. X to the 3rd has a 3 coefficient. X squared is missing, so that's a 0 coefficient. X is -5. And then 4 is 4. I'm going to draw my line because I know my remainder is going to be under my 4. All right, any questions on the setup? That's the biggest thing. Once you set it up, it sort of kind of comes along. How do you start? Whenever you're here and you go, I forget how to start. How do you start? You got to bring down the first one, whatever it is. Now it's multiply, add, multiply, add, multiply, add. So -1 times 1 is -1. I'm going to add down. I get 2. Now I multiply 2 by -1. 2 times -1 is -2. I add down, I get -2. -2 times -1 is +2. I add down, I get -3. I have one more to do. -3 times -1 is +3. I add down, I get 7, which is my remainder. How do I write the answer? Well, my highest power was a 4th power, which means when I start writing this answer, it has to be a 3rd power. I'm not going to write 1, but I know it's 1x to the 3rd, x to the 3rd. I go right down the line. Plus 2, what's the next power? X squared. minus 2, what's the next power? X. And what's the next power? None. If I start with a 3, I go right down the line, plus the remainder of 7 over x plus 1. Answer. If you happen to forget your 0, you will have a totally wrong answer. So it's really important to remember to always check that you have every power represented. Okay, let's do another one. 3. X to the third minus 2x squared minus 2x. Well, how if I look at the right one? Sorry, I looked at the wrong problem. Minus 2x squared minus 5x plus 6 divided by x minus 3. Number 1, do I have all my powers? It starts with a 3. I have a 2. I have a 1. I have none. Beautiful. I have them all. I don't need a 0. I'm going to do my elongated divide, upside down divide sign. And I look over what I'm dividing by. I'm dividing by x minus 3. So it has to be the opposite sign. I'm going to divide by 3. And then what I'm going to do, my coefficients. So my coefficients of x to the third is 1. X squared is negative 2. X is negative 5. 6 is 6. And that's going to be my remainder. So I put a line there for my remainder. And then how do I start? I don't know where to start because I forgot to do something. I have to bring down my 1. And then we're going to do multiply, add. So 1 times 3 is 3. I add down, I get 1. 1 times 3 is 3 again. I add down, I get negative 2. Negative 2 times 3 is negative 6. Oh, look at this. Remainder is 0. There is no remainder. So my answer is I started with a cube. My original problem is a cube, which means my answer is going to start with a square. X squared, you can put 1x squared if you want, plus x minus 2. And there is no remainder. And that's it. And then one more I want to show you just to make sure. I know this is sort of new. 2x to the fourth plus x to the third minus 3 divided by x plus 2. I should put that in parentheses. 2x to the fourth plus x to the third minus 3 divided by x plus 2. And I think you probably noticed that we're missing something. So we have, I always check first, do I have all my powers? I have a 4, I have a 3, I am missing a 2, and I'm missing a 1. We got to put 2 zeros in there. We don't have a square and we don't have an x. So up there, I have x plus 2, which means I'm change the sign of the 2 to a negative 2. I'm dividing by negative 2. My coefficients, x to the fourth is 2, x to the third is 1, x squared is 0, and my x is also 0. I don't have either of them. And I have a negative 3, and that would be my remainder. How do I start? I bring down my 2. And then we're going to multiply. 2 times negative 2 is negative 4. I add down, I get negative 3. Negative 3 times negative 2 is 6. I add down, I get 6. 6 times negative 2 is negative 12. I add down, I get negative 12. And my last one, negative 12 times negative 2 is 24. And I add down and I get 21, which is going to be my remainder. What was the highest power our original problem was? A fourth power, which means it starts with a third. So 2x to the third, right down the line, minus 3x squared plus 6x minus 12 plus 21 over x plus 2. Synthetic division. It's a pretty cool way to divide polynomials. Just remember that it has to be, it can only be, like we can't use this, we can't divide that. It has to be just the x in the front. I totally didn't see that, did you? All right, so you can't divide this, at least not yet. We're just doing it ones that have just an x with no number in front. There's one more thing I need to show you about this section. It's really a short thing. Sometimes you need to find the remainder without doing any division. So how do you find the remainder? You're going to need it in the future studies if you don't divide. So if I give you a polynomial and I tell you what I want to divide by it, how do I find the remainder like quick? All right, so like this. Let's see. Oh, by the way, this is called, let me write this down first. This is called the remainder theorem. This is what we're working on, remainder theorem. It's a theorem about how to find a remainder. So let's say I have this polynomial 4x to the 6 minus 25x to the 3rd plus 35x to the 4th plus 17x squared. That's my polynomial, and I want to divide by x minus 4. Actually, I'm going to change it. Let's do x minus 1. Make it easy because they're big numbers. But I don't want you to divide. I just want to know the remainder. What's the remainder? What is the remainder when you divide by x minus 1? That's really what we want to know. What is the remainder? We don't want to divide it. We can, but you need to, sometimes in math, what you're going to get to in that class, you got to do it quick. All right, this is what you do. If I were to do synthetic, what would I divide by? I would divide by 1. Remember that, 1. So what do? I had to find P of 1, which means I'm going to plug 1 in for x. So 4 times 1 to the 6 minus 25, 1 to the 3rd, plus 35, 1 to the 4th, plus 17, 1 to the 2nd. Okay, so 1 to the 6th is 1 times 4 is 4. 1 to the 3rd is 1 times negative 25 is negative 25. 1 to the 4th times 1 to the 4th is 1 times 35 is 35. And 1 squared is 1 times 17 is plus 17. I'm going to add these together. Let's see. That's negative 21. So that's 10, 14, 14, 14, 17, 11. I got 31. Anybody else get 31? 35, negative 21, that's 14 and 17. Yep, 31. Did 2 ways. All right, equals 31. What you just found was the remainder. To find the remainder quickly, you take what you would have divided synthetically by, whatever that number is, and you plug it in for x, and you will find your remainder. Let's look at another one. Say I want the remainder. Find the remainder me screw this up a little bit. Find the remainder. When negative 2x cubed plus 4x squared minus 8x plus 2 is divided by x plus 1. All I want is a remainder. I'm going to take what I would have divided by synthetically, I would have divided by -1, and I'm going to put -1 in for all my x's. Now we can simplify. -1 to the third power. Don't forget order of operations too. You can't multiply -2 times -1. Remember, we got to do this first, right? -1 to the third power is -1 times -2, which is 2, plus -1 squared is 1, times 4 is 4. -8 times -1 is +8, and then plus 2. And we'll have 6 and 8 is 14, 15, 16 is my remainder. So I say the remainder is 16. One question, what does it mean if you have a remainder of 0? Really important. What does it mean if you have remainder 0? I know if remainder is anything other than 0, I had things left over, right? But let's say there is nothing left over, remainder is 0. What does that really mean? We had one earlier. Let me just find it. Hold on. This one. We had 28x squared. I'm not going to do the whole thing. Minus 15 divided by 7x plus 3. And we did all our work. We got 4x minus 5. Remainder was 0. What does that mean? What does that mean? That means that this is a factor of that, which is also a factor of this is 7x plus 3, which means if I multiply 7x plus 3 times 4x minus 5, that has no remainder, I will get that polynomial out. They are factors. So when you have a 0 remainder means you have a factor of the given polynomial. In other words, it divides evenly. Again, just to sort of put it in place of like a number, if I have 36 divided by 4, let me make it just easier. 6 is 6. There is no remainder because 6 times 6 is 36, right? Remainder 0. If I have 50 divided by 25, the answer is 2. There is no remainder. That's because 25 and 2 are factors. Same thing with polynomial. 0 remainder means you have factors. They are factors of the given polynomial. And that concludes 6.4. Synthetic division is pretty cool. I like how it works. Okay, let's start 6.5. Hopefully I can get enough done. If not, I'll add it to the next class. 6.5. Solving equations containing rational expressions. something like this. Always means like solve for x, right? It's always solve. 5/3x plus 1 equals 7/6. So rational means fractions. So how do I solve an equation that has fractions with x in the denominator? That's what it's saying. There's two ways to think about it. I'm going to do each way. So I'm going to put this one over here just for the second way to talk about it. We have fractions. We need common denominators, right? So the first way is by finding common denominators. What would be my common denominator? Well, I have 3x. 1 is over 1. So that has a denominator of 1, and 6 is 6. So I think we can make all the denominators 6x. And we write it so that they do have the denominators, each of them of 6x. And you're going to figure out what we have to do to fix it. Okay, so I need 6x. I have 3x, which means I got to multiply this one by 2, which means I multiply that by 2, which makes 10. I need 6x. I have 1, which means I multiply by 6x, and I get 6x, which makes sense because 6x divided by 6x is 1. I need 6x, I have 6. That means I gotta multiply this by x and multiply it by that by x, and I get 7x. Now, once all the denominators are the same, this is only for when it's equal to. Once all the denominators are the same, you don't need them anymore because they're all the same. All we need is the numerator. Only for equal to. When all the denominators are the same and you have an equal to, you don't need the denominator. And that's because I can multiply everything by 6x and all the denominators will cancel out. You can remember it that way. You just remember it by once they're the same, you don't need them. And then we solve. Minus 6x minus 6x. 10 is equal to x. My answer is 10. Of course, you want to check your solutions by plugging it in and making sure it's true. We'll talk about that after I do this problem a second way, a different way. And the other way to do this problem, which you might like better or not, is you figure out what the common denominator is, which is 6x. I multiply everything by 6x. I'm going to put it out here. I don't have room, which means I'm going to distribute 6x to everything. So 6x times 5 is 30x over 3x plus 6x times 1 is just 6x, but I'm going to put it over 1. Because remember, 6x is over 1. You only multiply the numerator. 7 times 6x is 42x divided by 6. And what happens is you actually get rid of your fractions because they're going to simplify. 30 divided by 3 is 10. X is gone. Plus 6x equals 42 divided by 6 is 7. And look, we have the same equation on both sides. So this technique is you multiply by common denominator first, and then solve. Really depends on which one you want, you like. Okay, so I said check your solution, always check your solutions. And here for this particular problems, these problems, it's really important to check your solutions. Okay, sometimes for these problems, you will get an answer that is impossible or not true, whatever you want to think of it as. So you'll actually get an answer, but it can't be an answer. And I'll show you when it's not an answer. This is not an answer. This is not an answer. We call it an extraneous solution. Which means I got an answer doesn't work. I have an answer that doesn't work. That's what that means. So you want to always check your answers. Always check your answers. Okay, so let's do another problem. Always check your answers. Two, let's look at a problem like this. 1 over 2x minus 1 over x plus 1 is equal to 1 over 3x squared plus 3x. Really similar to when we added and subtracted these. Same kind of idea. Now, what we do have to do first, though, is to factor denominators if we can. Just like when we add and subtracted, we can factor this because we need to factor it to find a common denominator. So I'm going to rewrite it. Take the 3 out, take the x out. That's my greatest common factor, and x plus 1. And you'll see why we had to do that, because now we can find a common denominator. Common denominator, so I have a 2x, x plus 1. So I know it has to have an x plus 1. They all have to have x plus 1, and they all have to have an x. And 3 and 2, that's going to make it 6. So our common denominator is going to be 6x, x plus 1. Minus 6x, x plus 1 equals 6x, x plus 1. All right, so where we multiply 2x by to get 6x, x plus 1? Well, 3 to make 6, and we already had the x plus 1. So this is going to be multiplied by 3, x plus 1. So this becomes 3, x plus 1. The second one, we have x plus 1, so we just need to multiply it by 6x, which means 6x, that is 6x. The last one, we have x plus 1, we have an x, we have a 3, we're only missing 2. 3 times 2 to make 6. That would be 2. Now that we have the same denominator, we can ignore it and go to writing our numerator down. And now we have a basic algebraic equation we can solve. Distribute 3x plus 3 minus 6x is equal to 2. Combine like terms. Negative 3x plus 3 is equal to 2. Subtract 3. Negative 3x is equal to negative 1. divide by -3, divide by -3. X is going to be positive 1/3. And then you want to check your solution. And when you do, you'll find it is 1/3. It works. You guys have calculators, so just put them in the calculator, 3 parentheses, 1/3 plus 1, and go from that, and you'll see you have the right answer. All right. Let's do one more. Well, yeah, I only had a chance for like one little tiny one. Okay, so just a tiny one. We can do a tiny one. Then I'll pick up on these later on when we come back. Okay, this one should you recognize? You should recognize this. As a proportion, right? I would not even get common denominators. Why? How do you solve a proportion? Cross multiply. That's what I would do. So cross multiply. If I multiply this, I get x plus 1. If I multiply this, I get 2 parentheses x minus 1. I solve it from there. So yes, you could get common denominators and get the same thing, but if it's a proportion, just cross multiply. So x plus 1 is equal to 2x minus 2. I'm going to subtract x. Again, you can do it any way you want, any order you want, as long as you get the right answer. Plus 2, plus 2, x is 3. Again, plug it in.